Good morning and namaste. We are from Fellowship School, Mumbai, Maharashtra. My team name is Fellowship School Innovators. I am Pranav Dekar and my team members are
Aditya Arnav Prasad.
Today we are going to speak about a project, the Green Spark, which is under the Viksit Bharat Vision 2025, which is under the theme Atmanirbhar Bharat. Now imagine, people are planting more plants because you want to light a bulb. Isn't it amazing? No, I'm not sure. It is possible. Now the question is, we can devise so many plant-based products from plants. Then why not electricity? Because the electricity generated from non-renewable sources are harmful to the environment, and after a long period of time, these sources may become extinct, for which we need a more sustainable form of energy. As an alternative of these non-renewable sources, we have come up with the idea of using living plants. Our project is based on a natural process which is safe both for the plant and the environment. In our process, we have used the process of photosynthesis, which is a process from which green plants make their own food and some certain microorganisms convert the solar energy to chemical energy. We capture solar energy which mainly contains water, carbon dioxide and minerals get converted into oxygen and energy rich compounds.
Let's see the problem statement. Lots of articles printed in newspaper and various social media regarding the problem of depletion of non-renewable sources and its hazardous effect on our environment.
Now I'm going to justify the goals of a project. The aim of a project to harness natural processes within plants to produce electrical energy in an environment-friendly and sustainable manner. The objective of a project are to plant as a new alternative to electricity, to reduce the burden of use of non-renewable sources, eco-friendly as a process to the nature. We have used three methods in conduct a project: survey method, experimental method, and interview method. The first method, survey method, we have conducted survey in Mumbai Central, Grand Road, Paikala, Borivali, Mira Road, and in the areas in Mumbai. And from the question, on the analysis of questionnaire, in question number one, and we conclude that question number one, option C, implies that most of the population is unaware that plants as can be an alternative for producing electricity. In question number four, we can see that question number C is prominent. It shows that most of the population is aware of the potential benefits, of producing electrical plants and to reduce the burden of fossil fuels. Now, we have conducted methodology to execute a method. We have conducted five experiments. After we conducted five experiments, we can conclude that we work on the selection of electrodes and plants. And from the table, you can see that whenever we use copper and iron, the voltage was 0.7 to 1.20, but it was fluctuating. But when we use carbon and aluminum, the voltage was also between 0.5 to 1.2, but it was fluctuating. So we did discussions and selected copper and zinc, which gave 0.86 to 0.97 volt and was more cost effective. And we did trials on different thickness of electrodes and came to conclusion that 3 mm of these electrodes are more stable and give more peace.
Plant selection. After checking the voltage in the digital multimeter, we finalized the plants which generated more voltage. The plants are tulsi, hibiscus, aloe vera, and brass. In this observation, we also saw that the electrode should be inserted near the roots of the plants. Though the plants were 4 to 8 months old, therefore they had developed roots and stems. In experiment 2, we have collected the data on the basis of the observation of day and night. So the following data is of Tulsi of early morning is 0.87, after watering is 0.97, and at night it's 0.9. Same with hibiscus, it's 0.85 in early morning, 0.98 after watering, and 0.92 in night. Aloe vera is 0.90, 0.95 after watering, and 0.91 at night. Braphanum is 0.99, 1.05 after watering, and 1.01 in night. And we have used red soil for planting and no fertilizers were added. We have also made use of the salty water to see if the electricity was generated more. But the plants got dried up because of this soil. We also researched on the non-green or less green plants like the cactus. The electricity was generated, but it was fluctuating. So we came up with the idea of researching on the plants which have chlorophyll. And we came up with the plants which have having rhizobium roots like the soybean, chickpeas, etc. In experimentally, we have connected the roots of the plants in the series of the to generate electricity with the help of the electron. In this, we came up to with the reaction that glucose is oxidizing on anode to form glucolactone and oxygen is reduced in the cathode to form water. Observation. In this, glucose is generated by the plants in the process of the photosynthesis in which electrodes is placed near the roots of the plants and the in the biochemical bacteria the carbon dioxide, proton and neutron are placed near the roots in which carbon dioxide returns back to the atmosphere and the ion attracts towards the electrode to form electricity using the sustainable sources.
About the microbial fuel cell. A microbial fuel cell is a bioelectrochemical system making use of biocatalysts for conversion of chemical energy into electrical energy. A microbial fuel cell is a device that can convert chemical energy into electrical energy with the help of some microorganisms. In a project is obtaining the electrical energy from living plants and the effects of temperature, humidity, and soil moisture. Soil moisture on leaves is also studied. Plants photosynthesize organic matter with the help of carbon dioxide and water for its growth and capture solar energy. A little amount of organic matter is excreted as waste product. Naturally occurring bacteria, which are electrochemically charged, break down this organic matter into the rhizosphere and produce electrons. Electrons. When electrodes are placed near the roots or in the soil, the ions are attracted toward the electrode, thus forming electricity from the surge.
In experiment 4, we have attached 4 to 6 plants together to generate voltage and we were able to generate more than 4.46 voltage and we were able to light up a 3 volt bulb. 3 volt bulb. At first, it was fluctuating. So we conclude that we need a digital device to store the energy. So we added the capacitor and the switch so that the energy can be stored when it is not in use. We also concluded the factors like humidity, moisture, and temperature for the generation of the electricity. We have also got the equation in which V is equal to C into R, where V is the potential difference measured in volts. C is the current difference, R is the resistance, in which we got the readings in the volt millimeter, which is converted as millivolt. In experimenter 5, we have successfully generated electricity with the help of the plants, and this can be a new alternative for generation of electricity. And it is also a good conservation of ecosystem. We have successfully generated electricity from home plants, and this reduces the burden on the non-renewable sources. Our project is 100% eco-friendly as we have not harmed or damaged any of our plants.
Let's see the results. First, cost-effective management. Second, cleaner and more sustainable energy. Third, crucial for reducing dependency on fossil. Fourth, non-renewable fuels. Fifth, encouraging ecosystem restoration, reforestation, and promoting healthier ecosystem. Sixth, energy access and empowering local population. 7. Stimulate economic growth. Conclusion. We can conclude that electric current is produced successfully by studying its effects of various parameters, and thus we can produce electricity in cost-effective and eco-friendly manner.
Now I will talk about polar action. First, to increase the series of connections in order to increase the voltage. Second, to check the voltage generation from other plants. Third, to research on other plants and more old plants. As we have planned two plants, oak and round chickpeas, as they have rhizobium roots. We can check the voltage once the roots are developed in few months.
As we have justified the theme Atmanirbhar Bharat, which we have made a proposal to produce electrical energy from plants, which is a novel self-reliant case, which makes the case strong for Atmanirbhar Bharat. It also has sustainability and durability.
Thank you.